Okay, great. So let's take a look at this one. So is this a function or a relation? I should make this smaller.
Function?
Yeah. Every person, oops, my bad. Every teacher, no, it's every X. The teacher has only one Y subject. Okay, what's my domain? Squiggly line and then Tenson. This is the hard part. Haskins. Jones. I think Jones retired because Jones, I don't remember Jones. Poe. She's the dean now. Woods. And Carbone. And then the range would be the subjects. So the subjects are math. You can short these: anthro, psych, and bio. Okay, so then the other part, I'm just going to do the X comma the Y. So this becomes math, comma Henson, anthro, comma Haston, psych, comma Jones, bio, comma Ho, math, comma Woods, and bio, comma Carbone. Okay, now is this a function or relation? It's a relation. Why? Because, for example, math has two teachers, right? So your X has two Y's, two outputs. Okay? What's my domain? Domain, remember this one becomes that one, so this would be math, anthro, psych, bio, and then this one goes down to here, so that's the Henson, this is going to be long, huh? Aston, Jones, O, Woods, and Carbone. Okay, good. Next one, down here, Fahrenheit to Celsius, functional relation. So does every X value have only one Y value?
Yes.
Yes. Every degree Fahrenheit goes to 1 degree Celsius. My domain is degrees Fahrenheit. My range is degrees Celsius. My inverse, I'm just going to write out the flips of these guys. So 0 degrees Celsius is 32 degrees Fahrenheit. 20 degrees Celsius is 68 degrees Fahrenheit. 40 degrees Celsius is super hot, 104, 4 degrees. Who's ever traveled to a country where they do Celsius instead of, yeah, it's a little bit, it's always a little bit weird, you gotta kind of like adjust a little bit. 6 degrees Celsius is almost boiling, it's hot. Okay, now, is this a function or relation?
Function.
Function, right? Every degree Celsius has only 1 degree Fahrenheit. It matches up only 1 degree Fahrenheit. So my domain is degrees Celsius. My range is degrees Fahrenheit. Good. They're both all real numbers. Well, that's not true. That actually, well, it gets more complicated than that, but yeah, they're all degrees Fahrenheit, all possible degrees Fahrenheit, and all possible degrees Celsius. I think that degree Celsius goes down to negative 273. Kelvin's is 0 degrees Kelvin is negative 273. But that's not a big deal. Okay, all right, let's move on to the next page. So a functional relation may be defined by a set of ordered pairs. We may give the set of ordered pairs a name. For example, this set of ordered pairs is called F. F is 1 goes to 2, 2 goes to 3, 3 goes to 1, 4 goes to 4. Or here's another set of ordered pairs, R, we call that capital R, and has these sets of points. The symbol R inverse. Do you see that R negative 1? Do you see that negative 1 in the corner as the exponent? Everyone see that? Yeah. Right up there. That's what we call inverse. So it's R inverse. It means the inverse of the function. It's read R inverse. The symbol F to the negative 1 is read F inverse. So this is F inverse. It'll be worth, I think, like 1 point on the exam if you can identify that symbol correctly, or write that symbol correctly. So F inverse, you take the x and the y, you swap them. And again, I would say swap. Don't use switch or flip, use swap. Because that will can make sure swapping means the x and the y switch places. So 1, 2 becomes 2, 1. 2, 3 becomes 3, 2. 3, 1 becomes 1, 3. 4, 4 is 4, 4. That's its own inverse. So, and then here's R inverse, right? It's a swapping of all those guys. When a set of ordered pairs is a function, we can use function notation to write out the relationship given the ordered pairs. So, for example, here, the point 1, comma 2, 1 goes to 2. So, this is my x, this is my y. Everybody on board? So 1 is my x, 2 is my y. Yes? Okay. So that means here, this right here, f of 1, is that my x or my y? F of 1, the whole thing.
Y.
This is my y. My y is what? My y equals 2. My y is 2. What's my x?
1.
1. So when x is 1, y equals 2. Everyone make sense? Everybody with this?
Mm-hmm.
What's another one that I could write? I would write f of, so from here, I could write f of what? 2. 2 is my x. What's my y? 3. Since this is my y, it equals 3, right? Because this is 3 and this are the same thing. They both mean y. Everybody on board with this part?
Mm-hmm.
All right. So, for example, here's another function. You can rewrite it this way. Right? X is 1, y is 2. When x is 1, f of 1 is 2. When x is 2, y is 3. So f of 2 is 3, because this is my y, when x is 2. Here, 3 is 1, so 3 goes to 1, so I put in 3 into the function, I get 1. Here, I put 4 into the function, I get 4 in the function, I get 4. So f of 4 is 4. You can think of it like that way, right? I put 1 into the function, I get 2. I put 1 in the function, I get 2. That's another way of thinking of x and y. The inverse is when you swap the x's and the y's, right? So here you put 2 into the inverse, and you get 1. Here you swap 2 and 3, so here you put 3 into the inverse function, you get 2. So here when my x is 3, my y is 2 for the inverse. Same thing. You take the 3 and 1, you swap them, so you put 1 into the inverse, you get 3. Right? Everybody, all right, this part? Just using function notation. So here's some exercises. You're going to write them using function notation. So here are my points. Here's the first function notation. So point is Terry, comma, 2000. So f of Terry, that's my input, should give me what output?
2000.
2000. Everybody all right with that? Comma, and then do the other three. The inverse, right, the inverse of a set of ordered pairs. So heads up, guys, look up for a second. F inverse, F is the negative 1 power, inverse equals squiggly line, and then I'm going to put in each one of my points, only the x's and the y's swap. Right? Inverses, they swap places. And you're going to list out the rest of them. And then inverse function notation, you're going to do that same concept, x negative 1 of, now my input's 2000. 2000 is going to spit out what? Terry. Good. So everybody all right with that part?
Is it the same? B and C is the same?
Yeah, sort of. I mean, it's saying, I mean, you're going to list them all out.
Yeah.
This is it in point notation, and this is it in function notation.
Oh.
Right? Just like that, right? You
Oh, I
just,
got it. Okay.
yeah.
Point notation, function notation.
Yeah.
Okay.
so they mean the same thing. So these two are the function, right? And then these ones are the inverse below. These two below are the inverses. So
Yeah, I'm just trying to see.
this is F and this is F inverse. Yeah, these two below. And these two are,
Oh, that's a squiggly line on the B?
Yeah.
Okay, well, there's no squiggly line on the other side?
right, well, you haven't finished yet.
Oh, I
We're
got
just
you.
doing at the end.
Oh, okay,
I'm just doing the first ones for you guys. You guys are doing the rest.
I got you.
So you guys are going to finish that up. And then you will do the next one. And then give 3 and 4 a shot too. Give the rest of these ones a shot. So why don't you guys work on the rest of the page? And then we'll go over this. Should I talk about do you guys want to talk about the verbal one? Yeah, we'll talk about it. So verbal description. You know what, I'd rather read. Yeah. Okay, so why don't you guys work on the first two and then we'll go over, and when we get to next week, we'll go ahead and start on it. But I'll go over it when we get there. Just have this. Here's the single points, not function notation. So it's not function notation. This is a set of ordered pairs. You're saying F inverse is equal to the inverse set of ordered pairs. Just list the points. No, F. This is F right there.